This is me, trying not to fall asleep, but I'm 400 kilometers above the Earth. Hurtling around it at 17,000 miles per hour in a metal tube no wider than a school bus, and this is not your normal kind of tired. This is space tired. The kind of tired that makes you see things literally. You've probably heard about it. Astronauts seeing lights figures, even people that aren't there. Some say it's the lack of gravity. Others say it's just stress, but the real reason. It's much stranger than you think and much scarier. This is a survival story, a science story, a human story. And it's a warning because in space sleep is dangerous. And when you finally close your eyes, you might not open them the same way again, so buckle in, we're going on a mission. Okay, let's get something out of the way Hollywood lied to you. You don't just float up there in a calm, quiet, zen, like state. Peaceful, weightless, dreaming of Earth. No, that's not space. Space is a war zone, not with aliens. With your own biology. Your ears ring constantly from equipment hum. Your muscles start to break down within days. Your body slowly forgets how to move against resistance, and your brain? It never gets to rest. NASA calls it space adaptation syndrome, but it's not adapting, it's panicking. You're disoriented, nauseous, your circadian rhythm is in chaos. Why? Because on the International Space Station, you experience a sunrise every 90 minutes. Let that sink in. 16 sunsets and sunrises per day. Imagine trying to sleep through that now. Imagine doing it while your fluids float toward your head, your spine elongates, and your brain literally gets reshaped by the pressure. Yeah, welcome to space. It started quietly. 1969, Apollo 11, Buzz Aldrin and Neil Armstrong were orbiting the moon, and Buzz saw something, a flash, then another, bright lights, like fireworks. Exploding behind, closed eyelids, no source, no explanation. The mission log simply said light flashes observed. Phenomenon consistent with cosmic ray interactions. That was it back on Earth. They were dismissed. Just a weird side effect, a blip, but when the same thing happened again and again and again, 2 dozens of astronauts on multiple missions. Across decades, NASA had to face the truth. Space was affecting the brain in a way we didn't understand. And then came the hallucinations. Some astronauts described floating figures, others saw glowing orbs. One described a voice, female, calm, but unfamiliar, telling him to look behind. Another heard music from a violin in a ship with no instruments. These weren't dreams, they happened awake. Was it isolation, sleep deprivation, or was something else at work?
There is a storm that never stops, and it's invisible above Earth's atmosphere. You are bombarded constantly by cosmic radiation. These are high-energy particles, protons, heavy ions, atomic nuclei traveling near the speed of light. They come from solar flares, distant stars, even exploding supernovae on Earth. Our magnetic field shields us, but in space, you are completely exposed. Imagine standing outside in a hailstorm, except the hail is subatomic, and it passes right through your body. These particles collide with your DNA, they pierce your retina, and they mess with your brain. Literally, here's the theory: when a high-energy cosmic particle strikes the retina or the visual cortex, it stimulates neurons, creating the sensation of light. That's what those flashes were. Not light, not imagination, physics, but it gets worse. Radiation also creates free radicals, tiny molecules that damage brain cells. It alters neurotransmitters, triggers inflammation, disrupts the blood-brain barrier, and over long durations, it can lead to something deeply unsettling: spaceflight-associated neuroocular syndrome, or simply put, your brain starts to swell, your vision changes, and you start to hallucinate. You might think, just sleep it off. Wrong. Sleeping in space is a paradox. NASA astronauts are scheduled for 9 hours of sleep per night. They usually get 6, and it's broken noise, microgravity, motion sickness, and light pollution sabotage restful sleep. Melatonin levels drop, cortisol, the stress hormone, skyrockets. You're in constant alert mode. Even when you're resting, your brain thinks you're in danger over time. Sleep deprivation acts like a poison. Mood crashes, focus deteriorates, memory suffers, and after a while the line between dreaming and de-waking gets blurry. That's when the real risk begins. There's a story that never made it to the official logs. A Russian cosmonaut on a long-duration mission aboard Mir woke up one night and swore he saw someone outside the module. A man no suit staring through the window. He blinked, it was gone. He didn't tell anyone for days. Why? Because hallucinating in space could get you grounded forever. NASA and Roscosmos don't mess around. If you're seen as unstable, you're not going up again, no matter how experienced. So astronauts stay quiet. They write it in private journals. They tell each other in whispers, but they rarely report it back. Us in space, the line between fact and delusion is razor thin, and your career, it's hanging on that line. Back on Earth, hallucinations are rare, but in space, they're part of the experience. NASA now tracks cognitive performance during missions. They use neuroimaging, psych tests, reaction time metrics, and the data is clear. Long-duration missions degrade mental acuity. Sleep is less restful, focus drops, and hallucinations, both visual and auditory, become more common. Now, here's the terrifying part. We haven't even left low Earth orbit. All of this, it's from missions close to home. What happens when we go to Mars? A round-trip mission could take 30 months. No magnetic protection, no quick return, no real-time contact with Earth. Radiation will be constant. Sleep will be worse. Isolation deeper. The hallucinations potentially far more dangerous. NASA knows this. They're investing millions into shielding tech, cognitive monitoring, and even pharmaceutical countermeasures. But the truth is, we are not designed for space. So, how do astronauts survive? Here's how they do it. Number 1. Lighting control. The ISS uses dynamic lighting: blue light in the morning, red light at night. It's designed to mimic Earth's natural rhythm. Number 2. Pharmaceutical aids: melatonin, sleep meds, nootropics, sometimes even antipsychotics for extended missions. Number 3. Cognitive tasks. Astronauts are assigned games, puzzles, simulations, not just for fun. These track mental sharpness. Number 4. Exercise: 2 hours per day, mandatory, not just for muscles, but for brain chemistry. Number 5. Earth imagery. Looking at Earth reduces stress. It's called the overview effect. It reconnects astronauts with humanity. Number 6. VR therapy. Virtual forests, simulated oceans, digital nature is used to soothe overstimulated minds. These aren't luxuries, they are necessities, because space doesn't just test our machines, it tests our minds. Now imagine this: you're 6 months into a mission to Mars. You haven't seen real daylight in 180 days. You wake up, and you can't remember your crewmate's name. Your vision is blurry, and there's a faint tapping sound you can't explain. You turn your head, no one's there. You open the comms, it's silent because you're 12 minutes away from Earth at the speed of light, and you suddenly realize you might be the only one awake, and your mind, it might be lying to you. So, why do we go? Why risk hallucinations, brain swelling, radiation, madness? Why send humans at all? Because space is not just an adventure, it's a mirror. It reflects what we are willing to endure to push the boundaries of what's possible. And those hallucinations, they're not just malfunctions, they're messages from the mind. Maybe even from the cosmos telling us you are not meant to be here, but if you choose to stay, you must evolve. There's a moment, right before an astronaut returns home. They lie down, they strap themselves in, they close their eyes one last time in zero gravity, and as the silence surrounds them, and the stars drift silently past, they know one thing for sure: falling asleep in space is not just about rest, it's about trust. Trust that your mind will still be yours when you wake up. Trust that the ship is still moving. Trust that Earth is still out there waiting.